So let us move on to the next part, that is the friction. Okay, the frictional force. So now we know what is friction. Okay, so for an example, suppose we have this cupboard or a heavy block resting on the floor, and suppose this person, okay, suppose this is me, I want to push this block. So now I'm pushing this block, I want to move it from here to some other place. So I exert some force, the block does not move. Okay, what could be the reason? Yeah, there is a frictional force which is opposing me. I I increase the force and it doesn't move. What does it mean? That opposing force has also increased, right? Now there comes some limit beyond which if I increase the force, the opposing force will not increase. Okay, and then the block will begin to move. So that maximum value of the opposing force or the frictional force, it is known as the limiting value. Okay, it is known as the limiting value. So now from this thing, what can we infer? That there is some opposing force which we call as frictional force, the static frictional force. Why static? Because it wants to keep this block steady. Okay, it doesn't want relative motion between these two bodies. So there is static frictional force whose maximum value, which has got some maximum value, and if you exert some force which is less than that maximum value, the frictional force will self adjust itself equal to the external force. Okay, so suppose external force is 1 Newton, frictional force will also be equal to 1 Newton. External force is 2 Newton, the frictional force will also be equal to 2 Newton. Okay, external force is 10 Newton, the frictional force is also equal to 10 Newton. But now suppose the Fs max, the maximum value is 12 Newton. So if external force is 12 Newton, frictional force will be equal to 12 Newton. But if external force is 12.1, frictional force cannot be equal to 12.1. Then now what is origin of friction? What is origin of friction? So now we have these two bodies in contact with each other. So when we see just like this from our naked eyes, we can't see any irregularities between these bodies. Okay, but if we look through the microscope, we'll see that there are some irregularities, some heels and tails, okay, in these bodies. And so these heels and tails, they are interlocked with each other. Okay, that is one reason. So now when you try to move this body, okay, this body over this body, so what happens? Because of this interlocking, it's difficult to move. There will be some opposing force, okay, which is, you can say, the reaction between these two surfaces, right? So this is one of the reason. Then there is another reason. Another reason is molecular bonds. What are molecular bonds? So now see, these two bodies, they are in contact with each other. So some parts of these two bodies, they are so close, they are very close, such that atoms or molecules in this body and atoms and molecules of this body which are in this region, they can't distinguish between the two bodies. Okay, so what do I mean? That you have these two bodies, so atoms over here, they will exert forces in a particular region. Okay, that region is, we can say, 10 raised to minus 9 meters, okay, of the order of 10 raised to minus 9 meters. So atoms or molecules, they will exert forces on the atoms or molecules which are in this region. Okay, so the forces will be attractive or repulsive forces, it depends. So now, so see what happens. So for this atom, suppose, okay, suppose the distance is 10 raised to minus 9. So for this atom, these atoms of this body and these atoms, They are at the same distance. Okay. So the molecular force, intermolecular force exerted by this atom on these atoms as well as these atoms will be about equal, we can say, right? So what happens is temporary bonds are formed between atoms or molecules of this body and atoms or molecules of the other body. And because of these temporary bonds now, when you try to move one body over the another body, there will be an opposing force. Okay, there will be stretching of bonds, and the molecules don't like that, so they will attract sorry, they will exert an attractive force. So that is another reason of the friction. Is it clear? Yes, no? Okay. So there are these two reasons. There is this reason, interlocking, and another is temporary molecular bonds. All right. So now there are some laws of static friction. So these are the three laws basically. So Fs max, this is the limiting value of the static friction. It is directly proportional to the normal reaction. Fs max is directly proportional to the normal reaction. Okay. So if you remove this proportionality sign and put an equality sign, there will be a constant. So this constant is known as the coefficient of static friction. Okay, μs is coefficient of static friction. Then second law is Fs max. It does not depend on apparent area of contact. So it depends on normal reaction. That means it will depend on weight. If you keep a body on a horizontal surface. Okay. So now for an example, you keep some body. So you have wooden brick like this, suppose, and you keep it on some surface. So you keep it like this, or you keep it like this. Normal reaction will be equal, right? The normal reaction will be equal because weight is equal. So normal reaction in this case and normal reaction in this case, it will be equal. So now the area of contact in first case and second case, it is different, right? Area of contact is different. So the frictional force, the limiting value of frictional force, it doesn't depend on this area of contact. Okay. So it doesn't depend on the area of contact. Got it? Yes, no? Okay. And Fs max depends on the nature of two surfaces in contact. For different surfaces, the friction will be different. So this is like common sense. Okay. So these are the three basic laws of friction. All right. So after that, let's see the angle of friction. Okay. So suppose you have this body, this block resting on the surface, and now what happens is there will be some normal reaction due to this surface. It is equal to N, and the normal reaction will be equal to mg, right? So now suppose you exert some external force on this body. So you want to move this block, you exert some external force. So up to some value of this external force, the block will not move. Now suppose Fext is the value when the block just begins to slide. That means this value is equal to how much? The maximum value of the frictional force. So which will act in the opposite direction. Okay. So it is Fs max, right? So Fs max is in this direction. Normal reaction is upwards. You find the resultant of these two. So these two are the two contact forces which are exerted on the body. Okay. So one is normal reaction. The vertical component or perpendicular component is known as normal reaction. The component of the component of contact force along the surface is known as friction. Okay. So the net contact force is suppose R. It is the resultant of normal reaction and the friction. So you can find it out, right? So R will be equal to what? Square root of n square plus fs square. Okay. So in this case, it is fs max. So it is fx max square. This much would be the net contact force, you can say. And now see, this n will be equal to r cos theta. Okay, so theta is angle between this r and the normal reaction. So n will be equal to r cos theta and fs max will be equal to r sin theta. Okay, so then if you divide r sin theta by r cos theta, what do you get? Fs max upon n. So this is tan of theta. Okay, tan of theta is equal to Fs max upon n. We know what is Fs max. It is mu s multiplied by normal reaction. Okay, Fs max is mu s multiplied by the normal reaction. So you get mu s on right hand side, on left hand side you have tan of theta. That means mu s is equal to tan of theta. So this angle theta, the angle between the net contact force and the normal reaction, it is known as the angle of friction. Okay, this angle is known as the angle of friction. So what is angle of friction? It is the angle between contact force and the normal reaction, net contact force and the normal reaction. Is it clear? Okay. So okay, there can be one MCQ like this also. What is angle of friction? So there will be four options. For an example, one is the angle between the net contact force and normal reaction. Second is angle between the contact force and frictional force. Okay, so it's not angle between contact and frictional force, right? Then there can be a question, sorry, the option like angle between normal reaction and frictional force, etc., etc. Okay, so it's the angle between normal reaction and contact force, and mu s is equal to tan of that angle. Okay, so this is angle of friction. There is one more angle that is known as angle of repose. So there is one more angle which is related to friction. So see, now we have this body, suppose it is kept on this surface, a plank, and we can rotate that plank. Okay, so we can rotate that plank. So what happens now, at a particular angle, that body will begin to slide. So body begins to slide means that along that surface there would be some friction. Okay, and there is a component of gravitational force which will make it slide. So when that component of gravitational force, which is mg sine theta, it exceeds the maximum value of frictional force, we can say the body begins to slide. Okay, so it happens at a particular angle. So that angle is known as angle of repose. That angle is known as angle of repose. And angle of friction and angle of repose, they have the same value. Okay, angle of friction, sorry, angle of friction and the angle of repose, they have the same value. Okay, so in this case, now let's understand this diagram. So see, this is the body, okay, which is kept on this inclined plane, suppose. So now what are the forces acting on this body? One is gravitational force, which is acting downwards. One is the normal reaction. Okay, and one force is the frictional force. So frictional force will act along this surface. It always acts along the surface, right? So now body will tend to slide in this direction. Friction will oppose it. That's why it is acting in opposite direction. Okay, so in this direction. Okay, so this is a particular angle at which body just begins to slide. That means the frictional force will be maximum, and the external force has just matched the maximum value of frictional force. Okay, so now these are the three real forces: the normal reaction, the frictional force, and the weight. or gravitational force, you can say. Here, you will resolve gravitational force in two directions. So if this angle is theta, it will come out to be, this angle is 90 minus theta, you can say. So this angle will be theta. So this component is mg cos theta and this component will be mg sin theta. Okay. So then see, mg sin theta will be equal to fs max, mg cos theta will be equal to normal reaction. And if you divide mg sin theta by mg cos theta, you will get tan theta, which will be equal to fs max upon normal reaction. Okay. And we know that is equal to what? Mu s. Okay. So this theta is equal to, we can say, tan inverse of mu s, right? So in earlier case also, in case of angle of friction, we have mu s equals to tan theta. In this case also, you have for angle of repose, tan theta is equal to mu s. Okay, or mu s is equal to tan of this angle also. So angle of friction and angle of repose, they are equal. Is it clear? Yes, no? Okay. So then there is one more thing. Now we have to remember this acceleration of a body on an inclined rough surface. We need to remember formula for that. Okay. So see, suppose this is, okay, just like this previous case, we have kept this body on this surface. Okay. So the horizontal, sorry, there will be some gravitational force mg, and we have component of this force, the gravitational force along this surface, which is mg sin theta. Okay. And frictional force acting along the surface, it is mu s multiplied by n, right? It is mu s multiplied by n. And how much is n now? So if you can see here, n is equal to, okay, n is equal to mg cos of theta, right? N is equal to mg cos of theta. If there is no acceleration along this direction, okay, there will never be the acceleration in this direction. So n will be always equal to mg cos of theta. So you have n equals to mg cos theta, and the frictional force is mu s into n. So frictional force is equal to, you can say, mu s multiplied by n, which is mg cos theta. Okay. So net force along this floor, along this surface, will be equal to this force mg sin theta minus mu s multiplied by mg cos of theta. Okay. So net force is mg sin theta minus mu mg cos of theta. So therefore you get acceleration along this surface will be equal to what? So you write force is equal to mass times acceleration. You cancel out mass. So you get acceleration equals to g sin theta minus mu into g cos of theta. Okay. Is it clear? Okay. And we have to remember this formula. So now if mu is equal to 0, so body is sliding on a frictionless surface, then acceleration will be equal to g sin theta. Okay, this formula we had seen earlier. So now there is one increment only, okay, or one inclusion, we can say. Acceleration on a rough surface will be g sin theta minus mu into g cos theta. Okay. All right. So this is static friction. Then next comes the kinetic friction. So what is kinetic friction? So now when we slide some body, there will be some frictional force, and we'll have to exert a force which is greater than maximum value of that static frictional force. So now body begins to slide. So still there will be some frictional force. Okay. Still we need to keep on exerting some force if we want that body to move with constant velocity, right? So now there is sliding between two bodies. Okay. So now the value of friction between two bodies, it is less than the amount of friction in earlier case, that is in case of static. Okay, in the static case. So this case, when this block begins to move or body begins to move uh, over some other body, so in this case, the friction is known as kinetic friction, right? Because there is motion between two bodies and it is less than the static case. So there are same laws actually. There are some laws of kinetic friction and they are similar to the case of static friction. See, first law is Fk. So this is maximum value of the kinetic friction and it is equal to mu k multiplied by normal reaction. Okay. Then actually this value will be constant. So we can even uh, we can consider it is just Fk. Okay. So this value will be constant only, more or less we can say. We'll never consider that kinetic friction is changing. Okay. So actually, see, Fk max depends. Sorry, Fk max does not depend on the velocity. Okay. So Fk max does not depend on the velocity unless there is one velocity which is known as critical velocity between two bodies. Okay. So we'll consider Fk is constant only. There is no minimum or maximum value. Okay. So Fk is equal to mu k multiplied by normal reaction. Then second point is Fk does not depend on the area of contact, just like the case of static friction. Then it doesn't depend on the velocity and it depends on the nature of two surfaces in contact. Okay, so that is kinetic friction. And then now kinetic friction is less than static friction. There is one more friction we can say. So when we have a body rolling over another body. Okay, in this case now there is no sliding. So we can say at any time there is only one point of this body in contact with the surface. Okay, there is only one point of this ball in contact with the surface and that point of contact also keeps on changing, right? The point of contact keeps on changing as this body rolls. So in practice there should be no friction. Ideally I can say ideally there should be no friction, but what happens is when these two bodies are in contact, practically area there will be some area of contact between these two bodies. It's not like there will be only one point. Why? Because there will be some pressure. Okay, so there will be some weight and because of that there will be some pressure we can say on this portion and the portion gets deformed. Okay, it gets deformed. So this portion becomes little bit flat and that's why now there is more region in contact. So it is not like there will be only one point and that point will keep on changing. What happens now when you exert, sorry, not exert, when this body rolls over the another body, what happens is there is little bit sliding also. There is little bit of sliding also, and which will cause some friction. But this friction will be less than the static friction as well as the kinetic friction. And that's why in most of the cases, what we do is we make use of circular or spherical bodies. Okay, when we want to minimize the friction. Is it clear? Yes, no? Let's see this problem. A body of mass m is kept on a rough horizontal surface. Coefficient of friction is mu. Horizontal surface is applied, horizontal force is applied on the body, but it does not move. The resultant of normal reaction and frictional force acting on the object is given F, where F is. So you have a body which is kept on a rough horizontal surface. So this is the body. It is kept on a rough surface and there is some force exerted on this body. We exert this force, suppose external force, okay, F. And question is, it doesn't move the resultant of normal reaction and the frictional force. Tell me, what should we do? There will be some normal reaction, N, which will be equal to mg, and there will be some frictional force. Okay. Frictional force will act along the two surfaces. So this is Fs, right? So if it doesn't move, I can say Fs is equal to this external force. Let's call this external force F external. Okay, because they are asking the resultant of normal reaction and frictional force, they are calling it as F. So it's the resultant of normal reaction and Fs, which is F. Okay, right? So now it is simple. What will be F? F is equal to just square root of, you can say Fs square plus normal reaction square. Okay, and Fs is less than or equal to mu s multiplied by normal reaction, right? So you can put that here. So it is mu s square. So F will be less than or equal to, I can say, because Fs is less than or equal to mu s into normal reaction, this force will be less than or equal to mu s into normal reaction square plus normal reaction square. And how much is normal reaction? It is equal to mg. Okay, normal reaction is mg. So it is mg square. In the square root sign, you can take it outside. Take it outside. So you have F less than or equal to square root of mu s square plus 1. Okay, if you take mg common, right? Because n is equal to mg. Is it clear? Yes, no? Okay, this is a very simple question. Next question, assertion angle of repose is equal to angle of limiting friction. Reason, when a body is just at a point of motion, the force of friction of this stage is called as limiting friction. Tell me, which is the correct answer? Angle of repose is equal to angle of limiting friction. Okay, reason. So when will the angle of repose come? So when you have an inclined surface and the body just begins to slide, right? And that's why it turns out to be mu s is equal to tan of theta, tan of the angle of repose. Okay, and that's why we can say it is equal to angle of friction. So answer is both assertion and reason are correct, and reason is the correct explanation of assertion. Yes, no? Understood or not? Okay. And whether it is right or wrong. So see, when will angle of repose come in picture? When you have an inclined surface and this body just begins to slide. Okay. And in that case, we had seen the derivation that mu s is equal to tan of that angle. Okay. Angle between the horizontal surface, horizontal direction, and the inclination of plane. Okay. So that angle, tan of that angle is equal to mu s, and tan of angle of friction is also equal to mu s. Okay, and therefore you can say angle of repose is equal to angle of friction. Okay, so it's option A only. Yeah, when a body just at the point of motion. So when it just begins to slide, then only the friction at this stage, it is known as limiting friction. Okay, friction at this stage will be limiting friction. So now see what is happening here. So body is just begins to slide. Okay, at that stage only we find out this angle. Okay, and we also find that tan of this angle is equal to mu s. Okay, so that's why angle of friction is equal to angle of repose, because tan of angle of friction also it is equal to mu s. Yes, no. Okay. Next, which one of the following statements is incorrect? Frictional force opposes the relative motion. Limiting value of static friction is directly proportional to normal reaction. Rolling friction is smaller than the sliding friction. Coefficient of sliding friction has dimensions of length. Okay, what is dimension of option D? Right. What is dimension of coefficient of static or kinetic friction? No, no. What is dimension? So this is Fs divided by normal reaction. Okay. This is a force. This is also a force. Right. So dimensions are cancelled out. It is dimensionless. Dimensionless. Okay. Let's see next problem. A box of mass 2 kg is placed on the roof of a car. The box would remain stationary until the car attains a maximum acceleration. Coefficient of static friction between the box and the roof of the car is 0.2 and g equals to 10 meters per second square. The maximum acceleration of the car for the box to remain stationary is. Okay. So see, what do you have in this question? You have a box whose mass is given m equals to 2 kg. It is kept on roof of a car. So this is a car, suppose. Okay. Then it remains stationary until the car attains a maximum acceleration. So car is accelerating, but box is not falling. Box is not sliding until it until it attains some acceleration. Okay. So the coefficient of static friction is given. So mu s is equal to 0.2 and g is 10. So question is, how much would be that maximum acceleration? Tell me, what should we do? So let's imagine that this body was at rest. Okay. So now this one is sliding with some acceleration and it tries to remain at the same place. So it will fall down. Okay. Somebody who is looking this motion, for him, if you see in the frame of reference of this car, what is happening? This body is moving in backwards direction, right? Actually, what happens is this body is not moving in backwards direction. What is happening? This body is moving in forward direction. Okay, this one is sliding. Okay, from below. Yes, no? Okay. So, yeah. So now what happens? Because there is frictional force. Okay. So we can imagine this as from the frame of reference of this body, we can, okay, we can say that this one is moving in backwards direction with some acceleration. So we can imagine some virtual force acting on this body, okay, which is equal to F, and some frictional force will be there which will try to keep it fixed. Okay, so which will try to move it along with this car. So that frictional force is Fs. So now till the time this virtual force, we can say this virtual force doesn't exceed the frictional force, the body will keep on moving along with the car. Okay. How much will be the value of this virtual force? It will be just equal to mass of this body multiplied by acceleration of the car. Okay. So F is equal to Fs, we can say, till that time this body will keep on moving along with the car. Once this F exceeds Fs, okay, once this mass times acceleration is greater than Fs, what will happen? The body will, so we can say the car will slide from below, okay, and we can see as if this body is sliding in backwards direction. Okay, so how much is Fs? Fs is equal to mu s multiplied by mg. So m and m gets cancelled. Acceleration is just equal to mu s multiplied by g. So this is simple. So a is equal to mu s is 0.2 multiplied by g is 10. That is 2 meters per second square. This is the answer. Is it clear? Yes, no? Next question. A marble block of mass 2 kg lying on ice when given a velocity of 6 meters per second is stopped by friction in 10 seconds. Then the coefficient of friction is. So now there is a marble block, this block which is moving on ice. It is moving on ice, okay, and it is stopped by the frictional force in 10 seconds, okay. Then the coefficient of friction is. This is the question. So what should we do? Friction divided by mg. Okay, but here some condition is given, right? You have some initial velocity and it is stopped. So what you can do is you can find out the deceleration of this body. Okay. So deceleration is final velocity minus initial velocity divided by time. Okay. Final velocity is 0 because body is stopped. Initial velocity is 6 meters per second and it stops in 10 seconds. Okay. So the deceleration is minus 0.6 meters per second squared. Okay. So this negative acceleration is because of which force? Suppose there is this body moving on a surface. It stops because of what? Frictional force. So this negative acceleration is because of frictional force. So how much should be that frictional force? This m times a. So Fs is equal to m times a. Okay, and it will be equal to mu s into mg, right? So actually, we in this question we need not find that frictional force is m into a. Okay, but if we want to find out, we should be able to find out. Okay, so here what happens is m and m gets cancelled. Okay, and a is equal to mu s into g, right? So from this we can find out mu s. So mu s will be equal to just a divided by g. So that is minus 0.6. G is 10. So it is minus 0.06, right? That's the answer. Option C. Got it? Yes, no? Alright. Let's see this next question. A smooth block is released at rest on a 45-degree incline and then slides a distance d. The time taken to slide is n times as much to slide on a rough surface on a rough incline than on a smooth incline. The coefficient of friction is, so time taken to slide is n times as much on rough incline compared to what? Smooth incline. This is given. So how much is coefficient of friction? So what should we do? Okay. So suppose this is rough incline. Oh, this is a rough incline and this one is smooth. Okay, this one is smooth incline. So how much is acceleration on this one? It was g sine theta minus yes mu I'm sorry, mu into g cos theta. And on this one, acceleration is equal to what? G sine theta. Okay. So acceleration will be more on smooth incline, right? So then time taken is different. So how can we compare these two cases? So see, they cover same distance. So let's say s is equal to ut plus half at square. Okay. But u is 0. So s is just half of a into t square for both of them, for rough as well as the smooth incline. Okay. So now we can say that AR is the acceleration on the rough surface, AS is the acceleration on smooth surface, and TR is time taken on the rough surface. So I can say AR into TR square will be how much? It will be equal to AS into TS square. Okay, because distance covered is same, time taken is different, right? Yes, no. Okay, distance covered is same. Half of 80 square is same. That means 80 square is same. Okay, so then you have, okay, what is given? What's the time taken? Time taken is n times as much to slide on drop incline than on smooth incline. So this TR is equal to how much? N times TS. Okay, time taken on drop incline is n times as that of smooth. So you have AR into n square is equal to AS, because this, sorry, this will be TS square. Okay, time taken on rough incline is n times time taken on smooth incline. Okay, so then you will have square of this thing, TS square and TS square will get cancelled out. So you have AR into n square is equal to AS. And then now we can substitute this thing. Okay, and we can find out mu, right? So here what I can say is, okay, so here what I can say is g sine theta minus mu g cos of theta into n square is equal to g sine theta. And how much is theta? Theta is given to be 45 degrees. So for this one, sine theta and cos of theta, it's equal. Okay. So you can just cancel it out, right? So we have g minus mu j into n square is equal to g. Okay. I have g minus mu j into n square. So g minus mu g multiplied by n square is equal to g. And therefore, I want mu So I will take that n square on the other side. So I have g minus mu g is equal to g upon n square. And then I can move this mu g on this side, g upon n square on the other side. So what do I get? G minus g by n square is equal to mu g. Oh, before doing that, I could cancel out g. So anyways, g gets cancelled out. So mu is equal to what? It's equal to 1 minus 1 upon n square, right? It is 1 minus 1 upon n square. So it's option C. My calculation is correct. Okay, let's check it once. Oh. I'm sorry. I just saw this thing. I just saw mu. I just saw 1 minus 1 upon mu n square. Actually, it is option A. Okay, this is kinetic friction only. Body sliding. So good. Yeah, it is option A only. Okay, this is kinetic friction. Oh, sorry, I didn't see the. I just saw mu. I didn't check the coefficient if it is mu k or mu s. I thought it's 1 minus 1 upon n square in this option only. Okay. Yeah, so it's option A. Mu k is 1 minus 1 upon n square. Good. All right. Let's see next question. A block of mass 2 kg is placed on the surface of a trolley of mass 20 kg, which is on a smooth surface. Coefficient of friction between the block and the surface of trolley is 0.25. The horizontal force of 2 Newton acts on the block. The acceleration of the system in meters per second squared is. Okay, so you have a block, it has got some mass, and there is a trolley of mass 20 kg. So mass of this block is 2 kg, and there's this trolley whose mass is m is equal to 20. So let's call it capital M. Okay, 20 kg. So now what happens is, so they are on a smooth surface. Coefficient of friction between block and the surface of trolley is given. This surface has coefficient of friction 0.25. If the horizontal force of 2 Newton acts on the block, the acceleration of the system in meters per second square is. This is the question. So the system is accelerating. This is given. Okay, the system is accelerating. All right. So if it is not given, we have to check actually. Okay. So the system is accelerating. That means the net force, horizontal force of how much? 2 Newton acts on the block. So let's suppose some horizontal force acts here on this block. It is 2 Newton, right? So the system is accelerating. This is given. Okay. If it was not given that system is accelerating, then we had to check. How can we check? See, what happens here is, so we need to understand this, okay, very precisely. So you are exerting some force. Now, what will happen if this force is less than the frictional force or greater than frictional force? The two things will happen. This force is not acting on this body, right? It is not acting on the trolley. It is acting on this block only. Okay. So there will be some coefficient of friction. That means there will be some frictional force here which will be opposing this external force. And if this external force is more than that friction, then this block will slide with some acceleration over this trolley. Yes, no? And the resultant force will be equal to what? This external force minus the frictional force. Okay, that's one case. Now, if this external force is less than the frictional force, in that case, what will happen? Will this block slide? Yes or no? External force is less than maximum frictional force. It will not slide. Okay, then what will happen? Now, this block and the trolley, they are stuck with each other. And it's like this system is, okay, this is one system. And you are exerting this force on this one system. Okay, if there is no internal movement, if there is no sliding, right? So we need to check that. Okay, so frictional forces, is it given? Coefficient of friction is given. Okay, mass of this block will be 2 kg. Okay, so mu equals to 0.25 and Fs will be equal to how much? Maximum value of Fs is mu s into m into g. So that is 0.25 multiplied by m is 2 multiplied by 10. So this is 20 times 0.25, or you can say 1 by 4. Okay, so this is 5. Okay, it's 5 Newton. So actually, the maximum value of frictional force is greater compared to the externally applied force. So there will be no sliding, right? So this is like one system only. Okay, this is like one system only which will be moving together. There is no sliding. Okay, so we need not check this because it's given in the problem that the acceleration of the system, they are asking that acceleration of the system. Okay, not the block, not the trolley, the system, whole system, right? But if it was not given, okay, we need to check. All right. Anyways, so is this clear? Yes, no. Okay. We checked because we want to understand. We wanted to understand, right? It is not needed. Why? Because it's given that it is acceleration of the system. Okay. But it will be needed when it is not given. We need to check. Okay. Clear? Yes, no? Okay. So then, yeah, then the net force acts on this total system only. How much is total mass of the system? Find out m total. It is equal to m plus capital M, that is 22. So acceleration will be equal to just F divided by this total mass, and that is 2 Newton upon total mass is 22, right? 2 plus 20. So 2 upon 20 is 0.1. It's less than that, little bit less than that, 0.09. 0.09, right? Option D. So yeah, this is a simple question, and if we don't check this, it will take 20 seconds or something, right? Let's see next question. What is the maximum value of force F such that the block shown in the arrangement does not move? So this is the force F which is acting on this block and it doesn't move. So what should be the maximum value of this F? This is the question. Okay. So now what we can do is we can resolve this F along two components. So one would be the vertical component, one is the horizontal component. Okay. This angle is 60. The horizontal component is f cos 60 or f cos theta, we can say. Vertical component is f sin theta. And how much would be the normal reaction here? Will it be equal to mg? Actually, it will not be equal to mg. See, how do we find normal reaction? Okay, so in this case, what are the vertical forces? You have this block. Normal reaction will act upwards. Okay, weight of the block acts downwards, and there is this extra force. Suppose vertical component is acting downwards. Okay, so there is this extra force whose vertical component is acting downwards. How much is that? F sine theta. Okay, so now there is no acceleration in vertical direction. Okay, there is no acceleration in vertical direction. This body is not flying. So this n should be equal to what? Fs sine theta plus mg. Yes, no? Net force should be balanced. Okay, the force which is acting vertically upwards, same force should be acting vertically downwards. Then only there would be no acceleration in vertical direction. So I can say n is equal to Fs sine theta, not Fs, F sine theta plus mg. Okay, and I want F. So F sine theta is equal to n plus mg. No, n minus mg. Let's keep at that. Then what is happening? It does not move. That means you can say Fs is equal to what? It's mu s into n, and it will be equal to horizontal component of this force. Okay. So horizontal component of this force is acting in this direction. So frictional force will act in the opposite direction. This is Fs. Okay. Not moving means Fs is equal to F cos theta. Okay. So then Fs is equal to F cos theta you have, or F cos 60. And from this one you can find out normal reaction. Okay. So we have mu s is given. Yeah, mu s is given. It is 1 upon 2 root 3. So then n is equal to F cos theta divided by normal reaction. Okay, normal reaction, sorry, normal reaction is F cos theta divided by mu s. And I can substitute this over here. So let's call this one equation 1. This one is 2. I will substitute 2 in 1. So I get F sine theta is equal to F cos theta upon mu s minus mg, right? So then we can substitute values here, or I can move this thing on other side. Okay, so I will get F sine theta. Okay, I will move mg on other side. So I get mg is equal to F cos theta upon mu s minus F sine theta. F you can take common. Okay, F we can take common, and what do we get then? So mg is how much? M is root 3. Root 3 times 10 is equal to this thing. F I will take common. Cos theta is cos of 60, which is 1 upon 2. Okay, mu s is how much? It's 1 upon 2 root 3. So dividing by 1 upon 2 root 3 is equal to multiplied by its reciprocal 2 root 3 and minus f sine theta. So it is root 3. It's root 3 by 2. Okay. So this thing gets cancelled. 2 gets cancelled. You have root 3 minus root 3 by 2. Okay, so which will be root 3 by 2. And then what do you get? So this is root 3 by 2, right? This root 3 and root 3 by 2 will get cancelled. Take that 2 on other side. F will be equal to 20. Yes, no? Okay. Is there any confusion in calculation? Okay. So F is 20, right? We don't need extra page. Let's see next question. A wooden block of mass 8 kg slides down an inclined plane of inclination 30 degree to the horizontal with a constant acceleration 0.4 meters per second squared. The force of friction between the block and the inclined plane is, okay, block and inclined plane. So mass is given 8 kg, then theta is given 30 degrees and acceleration is given. Okay, the force of friction is asked. How much will be force of friction in this case? Right. No, cos theta. Right. Right. Normal is cos theta. So n in this case is equal to what? So this is mg. This angle is theta. This angle will be also theta. So it is mg cos theta. Okay. Always, if you have inclined plane, normal reaction will be equal to what? Mg cos of theta. And we know the frictional force is equal to what? Mu s multiplied by normal reaction. So it is mu s multiplied by mg cos theta. Okay. In case of inclined plane, always. Right? So we just need to remember this, that it is equal to mu s mg cos theta. So then it's simple. So mu s is given or not given? Mu s is not given, right? Okay. Inclination is given, acceleration is given. Oh no. Okay. It is not this way. Okay, let's solve this. So this thing we need to remember, not for this question only. We need to remember this always. So see, we can write acceleration will be equal to what? It will be equal to g sine theta minus mu into g cos theta. Okay. So g sine theta is g sine of 30 degrees. Okay. So I can say mu g cos theta is equal to a minus what? G sine theta, which is a. A is given, it's zero point 0.4 multiplied by 10 multiplied by sine of theta. Sine of how much? 30 degree. 1 by 2. Okay. So this will be 10 divided by acceleration is 0.4 only. By doing some mistake, mu g cos theta will be equal to, this is coming out to be, no, no, no. Yeah, I have done a mistake, no? Mu g cos theta will be equal to g sine theta minus a. right? I'm moving this on this side, so A will, okay, I'm moving A on this side, okay, so I had missed a sign here, right? So now there is no problem. So G sine theta is how much? It is 10 multiplied by 1 by 2, and you have minus A. So minus A is 0.4. Okay. So this is 5. 5 minus 0.4 is 4.6. Okay. And Fs is equal to mu into mg cos theta, or you can say m multiplied by mu into g cos theta, right? Okay. So we found this. It's 4.6. 4.6 multiplied by m. How much is m? So Fs is equal to 8 multiplied by 4.6. So it will be 40 less than 40. So option C. Yes, no. Any confusion in this? Okay. So yeah, we need this formula, and then after that we need to do some calculation also, right? Okay. So then let's see next question. A body of mass 100 gram is sliding from an inclined plane of inclination 30 degree. What is the frictional force if mu is equal to 0.7? So now mu is also given. So this is good. Okay. In this case, how much would be frictional force? Mu s mg cos theta. Right. So if it is sliding, it will be mu k. Now they are calling it mu only, so it can be mu s, it can be mu k. Okay, formula will not change. Okay, so it is just 0.7 multiplied by mass is 100 gram, which is 0.1 multiplied by g is 10 multiplied by, you have cos of theta, so cos of 30 degree. So 10 times 0.1 is 1, right? Root 3 by 2 multiplied by 0.7. Okay, option D. Okay. So this was simple. Let's see next one. A smooth inclined plane is inclined at an angle of theta with the horizontal. Body starts from rest and slides down an inclined surface. Then the time taken by the body to reach the bottom is. Okay. So how do we find time taken? This is a smooth surface. Okay. Smooth surface. So acceleration would be g sine theta. Okay. And this displacement is L. So L will be equal to how much? This is ut plus half at square. U is 0. Okay. Body starts from rest. So U is 0. So L is equal to half of at square, and therefore T square will be equal to twice L upon A, or you can say T equals to square root of twice L upon A. We want to find out this time. So that is twice L upon A is g sine theta. So let's check the options. Is there an option C? But this is L, there is H. Okay. Yeah. So L is there in only one option. It's not matching with that. That means we need to convert this L into H. So let's check. Okay. So H is equal to what? Or we can say in this diagram, sine of theta will be H upon L, or L will be equal to H upon sine theta. Okay. So it is 2 upon g sine theta multiplied by H upon sine theta. So sine theta square will be there in the square root sine. We can take it out. So it will be sine theta multiplied by, yeah, so option C, 1 upon sine theta multiplied by square root of 2h upon g, right? Okay, so this is clear. Okay, you had found it. Okay, good. All right, let's see another question. A block of wood of 1 kg resting on an inclined plane of angle 30 degree just starts moving down. If the coefficient of friction is 0.2, its velocity in meters per second after 5 seconds is, this is the question. Yes, block is resting. Hmm? Right. Right. Exactly. Let's do that. G sine theta, or G multiplied by sine theta minus mu cos theta. Okay. So it is 30 degrees. Sine 30, I'm sorry. In it is 10 times of sine 30 is half minus mu is 0.2. 0.2 multiplied by cos of 30 is root 3 by 2. Okay. So it is half 0.5 minus this will be 0.1. 0.1 multiplied by 1.73 is 0.17. Okay, let's keep that much only. So this will be 0. Okay, 50 minus 17 is 33, right? So 10 multiplied by 0.33 is 3.3. Acceleration is 3.3. Yeah. So after 5 seconds, so v is equal to u plus 80. So it is 3.3 multiplied by 5. How much? 15 plus something. Okay, 0.3. Yeah, will it be 16.15 plus 1.5? 16.5, right? Okay. It's coming 16.5 because I uh, approximated it here. It was 0.173. Okay. I removed that 3. Okay. I skipped that 3. Right. Otherwise, it would have come 16.35. All right.